Hi everyone. I've been getting some questions asking if I would make a video on how to do the quadratic formula and on what does it mean when it asks for a discriminant or to write down the number and the type of roots. Uh, so I'm going to just take some time and do that in detail with this problem. So you can find this problem in your notes, Unit 3, Section 2. It's on page 5 of your notes, and it's example 1. And here is the problem right there. And if you want to pause this for a moment and get your note packet out and ready, that's fine. And then get started. So here we go. Before we really begin, let's start by just really understanding what it's asking for. So a quadratic means there's this thing. If you were to graph it, it's going to make some parabola, right? And we want to know when it's equal to 0. So where does that parabola hit the ground? So just so you know, our goal in this problem is to figure out the places where this parabola hits the ground. So where does this parabola hit the ground? We've already done it over the past few weeks by just actually graphing it using our graphing calculator. And then in the last few days we've used factoring as well. The quadratic formula is another way of doing that, figuring out where does this thing hit the ground. So to use the quadratic formula, you have to actually know the quadratic formula. So if you're following along with me, let's write that down. So it is x equals the opposite of whatever b is, so negative b, opposite of b, plus or minus the square root of b squared minus 4ac all over 2 times a. We usually just say all over 2a. So that is the quadratic formula. So the next logical question is, okay, so what are a, b, and c? If you look at the original quadratic, whatever number is in front of the squared term, that's your a value. So in the problem we're doing, our a value is 2. The b value is always whatever number is right in front of the x term. In this case, it's 5. And the c value is always the number that is kind of off by itself at the end there. So in this case, the c value is 3. So let's start by just putting those 3 numbers into the quadratic formula. Let's ignore this idea of discriminant. Let's ignore the idea of number and type of roots. And let's just figure out where does this parabola hit the ground. So let's just use the quadratic formula now. So here we go. I'm going to kind of go like this. And x equals the opposite of b. So b is 5. So the opposite of that would be negative 5. Negative 5 plus or minus the square root of b squared minus 4ac. So b squared would be 5 squared minus 4ac. So 4 times a is 2 and c is 3. So 4 times 2 times 3. All of that divided by 2 times a. So 2 times 2. And now we're just gonna keep rewriting this, and we're gonna try to make it look nicer and nicer until we get something that tells us where it hits the ground. So let's keep going. Negative 5 plus or minus the square root of, let's see if we can do all of this part here. So 5 squared is 25, minus, let's see, 4 times 2 is 8. 8 times 3 is 24. So 25 minus 24 all over 2 times 2, we could just write a 4 there, right? That looks a little bit better. Let's keep going and making it look better and better. -5 plus or minus 25 minus 24 is 1. So the square root of 1 all over 4. And what is the square root of 1? Well, the square root of 1 is just 1. So I could just write a 1 there instead of the square root of 1. I'll do that. X equals -5 plus or minus 1 over 4. And at this point, you can't really simplify any of these parts anymore. -5 is as simple as it gets. 1 is as simple as it gets. 4 is as simple as it gets. So at this point, you notice that there's that plus or minus. That, it kind of makes sense that this problem would have a plus and a minus, because there are a possibility of 2 places where it could hit the ground. So you'd kind of think that our formula should be able to spit out 2 answers, and the plus and the minus does that for us. Once you can't simplify it anymore, that's when we can break it into 2 parts. So we'll go -5 plus 1, -5 plus 1 divided by 4. And let's see what we get there. So -5 plus 1 is -4. -4 divided by 4 is -1. It hits the ground at -1. So we just did -5 plus 1 divided by 4. Now let's do -5 minus 1 divided by 4. X equals -5 minus 1 divided by 4. So that would be the same thing as -6 divided by 4. Or that would be the same thing as -3 halves. So there we have it. We know that this parabola hits the ground at -1 and -3 halves. That would be the same thing as 1.5, right? So at -1.5, so it hits the ground right there and there. So we thought maybe it looked something like that. At that point I just didn't know what it looked like. Now we kind of have a little bit better idea. It looks kind of like this. I bet if you were to put this into your graphing calculator, it would look quite a bit like that. So the solution to the problem is x equals -1 and x equals -3 halves. That's the solution. That is where this quadratic right here will hit the ground. All right. I said we were going to kind of skip over these 2 things for a little while till we got to that point, and now we are to that point. So let's first talk about the discriminant. This had 2 answers. This parabola hit the ground 2 times, but I'd like to point out that it didn't have to be that way. Hopefully you would see that it's possible that a parabola could just barely touch the ground and bounce off. And in that case, it only has 1 solution. And I bet it wouldn't be too hard for you to imagine that it could also not have any solutions at all. Like, look at this one. This one never hits the ground. So a quadratic could have 1, 2 real solutions. Or it could have 1 real solution. Or it might not have any real solutions. But when that happens, it's just one of those weird things that we're going to talk about later in this course, But this does have two solutions. They're just complex, which means we call them imaginary numbers. And we'll talk about imaginary numbers in a little bit. But what you need to know right now is that if it doesn't have any real solutions, it has two complex solutions. So the number and type of roots. Well, this one, it had two real solutions, didn't it? It really hit the ground 2 times. So we know that this one has how many solutions? It has 2. And what type are they? They're real. 2 real solutions. And that leaves us with this discriminant business. What's that about? Well, it turns out there is a way of knowing whether the parabola is going to have 2 solutions like this one, or 1 solution like this one, or 2 complex solutions like this one, before you actually get done with the problem. A while back, I circled all of this stuff right here that was under the square root. Everything that's under the square root there, that is called the discriminant. If you just focus on that stuff that's circled there, you can know whether it's going to look like this one, 2 real solutions, this one, 1 real solution, or this one, 2 complex solutions. And it's because of the square root. You know, you've probably been told, or asked by teachers in prior courses, can you take the square root of a negative number? And they say, no, you can't take the square root of a negative number. And you put it into your, calculator. You try to take the square root of a number in your calculator that's negative, and it'll spit out an error at you. What that means is if you ever get to here and all of this stuff is a negative number, it's going to have 2 complex solutions. It's not really going to hit the ground. So if this had ended up being a negative number, it would have looked like this. But what we saw that when we did this, we got 1 underneath the square root. That's a positive number. And if you have a positive number, you can work with it. You can take the square root of a positive number. And then when you add 1 and subtract 1, you get 2 separate answers. That's why our problem had 2 separate answers. So if the discriminant is positive, that's another fancy way of saying if this number right here, when you get to this part of the problem, ends up being a positive number, it's going to look like this. It's going to have 2 solutions. If this number right here turned out to be a negative number, like let's say that number was -4 or something like that, that's when you would have had 2 complex solutions. So if the discriminant is a negative. And if the number is not positive and it's not negative, then the number is 0. If you take the square root of 0, you just get 0. And if you add 0 and subtract 0, you get the same number every time. And since you get the same number both times, that's why you only have 1 solution. So if this number right here had ended up being the number 0, then we would have said that the discriminant is 0, and we would have said that it had 1 real solution, so 0. So the discriminant in this problem was 1. That's a fancy way of saying what is it that you get underneath the square root sign. So the discriminant is the number that you get underneath the square root sign. So the discriminant is always that number right there. And if that number is positive, it looks like this. 2 real solutions. If that number is 0, that is 1 real solution.